We're here at Jack Buck's Farms this morning to talk about the AHDB project BOF77. This project is looking at the use of biocides in hot water treatment of daffodils. And we're here to look at the commercial application of chlorine dioxide this morning, as that's one of the techniques that we've been trialling over the last couple of years. So growers have been very concerned over the last few years since the loss of formaldehyde. So what we're looking at here is alternative biocides. Whilst the introduction of FAM30 has been a recent introduction and relatively effective, some growers are yet to be convinced by its efficacy. So this project is very much looking at a number of alternatives. Today we're looking at chlorine dioxide. So in the first year of the project, laboratory tests showed that chlorine dioxide was a very effective biocide. So the laboratory tests have shown that chlorine dioxide is very effective at very small scale. So we're now going to upsize it to see if it will work at a commercial scale. So a company called Scottmass are supplying the equipment and their expertise, and this is the first test at a commercial scale.
Scottmass are probably one of the oldest chlorine dioxide companies within the UK, if not actually Europe. We first established our research department to develop and work into the concepts of chlorine dioxide back in 1978, and indeed we're the first company in Europe to be given a license to sell chlorine dioxide for drinking water for human consumption. Since those days we've expanded into many different areas, which include Legionella control in hospitals, E. coli, salmonella control in food processing, listeria for fish, and we deal with many water treatment plants for waste disposal, recycling and many other applications. What we've got here is a somewhat prototype, rather rudimentary system. However, the principles of what we're trying to do are pretty much in our control in terms of the dosing and our evaluation of what we're actually achieving. What we've got down here at the bottom in terms of the chemical is a stabilized chlorine dioxide solution along with its counterpart chemical, which is an acid activator, and we'll explain just a little bit later on exactly why we require the two components. The pumping system, which is in the blue pumps there, are digitally controlled and allow me to actually control the dose milliliter per hour, either direction, up or down, of our target dose rate. The chemical is delivered up into the activation chamber, which is the grey tube which is going vertical. This is where the two chemicals come into contact with each other and a chemical reaction takes place which produces the free chlorine dioxide gas, which is then pumped into the tanks, and that is where it begins to do its job in terms of a biocide. As we mentioned, we have two chemicals which are used in our process. The first chemical, which is actually in the black drum here because it's affected by UV light, so we have to keep it dark, is the chlorine dioxide solution. The chlorine dioxide, when it's actually produced, is held in solution with a buffer because chlorine dioxide is actually a gas. Now, in this particular state, chlorine dioxide is considered to be biostatic, which really isn't much use to us, and we need to get the chlorine dioxide gas back out into its free solution again. And to do that, we have a second component, which is an acid, which is designed to strip down the buffer. In terms of chlorine dioxide, because of its power, the dosing mechanisms we have to be pretty accurate, because normally we're thinking of dosing in at 0.5 parts per million for drinking water, for example, up to maybe 1.5 to 2 parts per million in some food processing applications. So these pumps are digitally controllable for a number of different applications. We can actually control these pumps in terms of what we're doing here today for batch dosing down to 0.5 ml per hour in terms of the differential in concentrations. So these are highly sensitive and very effective pumping mechanisms which we have. What we're hoping to achieve today is to try and dose a rate of round about 3 to 5 parts per million. And the difference between the two rates is going to be determined by the residual value that we get from the wash water that we're using. So we have a mechanism of being able to evaluate almost instantaneously without doing microbiology. We can tell by what levels of chlorine dioxide are left what effect it should have on the fungus or the molds or the bacteria that we're trying to actually be challenging. chlorine dioxide is mutually exclusive with any of these microbiological loadings. So when you have one, you can't have the other. So it gives us a good advantage to be able to play around with dose rates so that we can hit the optimum both for microbial control but also for economics. As mentioned, we have a method of controlling or monitoring the residual value of chlorine dioxide, and this is one of the kits which we use. This piece of equipment here has electronic sensors which are dedicated totally to chlorine dioxide in its free state. So it doesn't take into consideration any other components or byproducts which might be in the solution. And as you can see, the water which we're actually working with is quite heavily soiled, large amounts of total dissolved solids in there, but that still doesn't affect the reading which we can take with this new unique piece of equipment which we have. The electrodes here actually sense the chlorine dioxide that's in the solution. So we get a very accurate reading within 60 seconds, and that allows us to adjust the pumping systems in accordance with the residuals that we're trying to achieve. And obviously, as this is an experimental stage, we need as much data as possible before we can actually convert this into the real economic solution that we hope to achieve. Of course, with all these sort of monitoring systems, however efficient that they actually are, tend to be a little bit labour intensive. So they're very useful in small scale applications. However, ScotMass envisage that we will be able to put onto the market at a very economical cost a fully automated system which will allow the growers to plug and leave and get on with other parts of their duties. So we have already got units like this out in the field in different applications, and we will take that technology and actually enhance it into the daffodil washing systems that we intend to provide.
So while Ewan is monitoring his chlorine dioxide concentrations, I'm actually more interested in the pathogen content of the water that's being circulated within the tanks. And I have a sample here of some very dirty, horrible water that's been in the tanks now for about a week. And what we're hoping that the chlorine dioxide is going to do is to kill any free living pathogens that are within this water. So this water comes back with me to the University of Warwick, where we will plate it out in petri dishes on a media, and we will basically assess if anything will grow. What we're hoping, of course, is that nothing will grow and that the biocide has been completely effective. And we should have those results fairly soon. So these bulbs have literally come out of the tank about 20 minutes ago. They're still warm to the touch, and what we want to try and do is to drive the moisture off as quickly as possible. So we have here a very small drying wall just for these 8 bins of bulbs, and they'll be on this wall for 2 or 3 hours just to drive the majority of the water off the bulbs. And the quicker that we can dry them, we reduce the chance that the bulbs will be reinfected with airborne pathogens. Once we've got them slightly dry or nearly completely dry, they'll go on to a bigger drying wall where they'll stay for a few days until they're completely dried through and the surface is dry to the touch. So the last stage of the process is evaluation, and we're doing 2 types of evaluation. One is looking at the water samples that have come out of the tanks, and that's a very real-time evaluation. But what, of course, we really want to know is what the bulbs look like next year and the following year. So the main evaluation will be next spring. The bulbs behind me now will be planted within the next 5 to 10 days, and we will then come back next spring when they come into their first flower, and we'll be doing assessments of the different treatments. And the treatments that we have here are basically untreated, so with no biocide at all. We have treatments with just the biocide, and we have a third treatment which is the biocide plus the fungicides. And there will be a 4th treatment when the farm goes back to using its original biocide, which I believe is FAM 30. So next spring we'll be back walking all the crops, looking for the big differences, or hopefully no differences, that we see between the plots. We will also do a subsequent 2nd year walkthrough.